the first law as a rate equation. We frequently find it desirable to use the first law as a rate equation that expresses either the instantaneous or average rate at which energy crosses the control surface as heat and work, and the rate at which the energy of the control mass changes. In so doing, we are departing from a strictly classical point of view, because basically classical thermodynamics deal with systems that are in equilibrium, and time is not a relevant parameter for systems that are in equilibrium. However, since these rate equations are developed from the concept of classical thermodynamics and are used in many applications of thermodynamics, they are included in this book. This rate of the first law will be used in the development of the first law for the control volume, and is this from the first law find extensive application in thermodynamics, fluid mechanics, and heat transfer. Anyway, consider a time interval delta t during which an amount of heat delta q crosses the control surface. For example, control surface. We have the W is done by the control mass. Let me write. Mass and delta Q enter the system, cross the boundary, and the time interval is delta t. Of Q, delta Q and delta W. In the internal energy change in internal energy change delta U, the kinetic energy change delta Ki, and the potential energy change delta Pe. From the first law we can write delta U plus delta Ki plus delta Pe for the first law of thermodynamics, dividing by delta t, the time interval energy added to the system, delta U, delta T, minus Taking the limit for each of these quantities as delta t approach to 0, we can make a limitation. We have the first limitation, delta u on delta t. We have du on dt, and the second one is also d Ki on dt, and the third one so the right hand side can be written as du on dt dki on dt plus dpe on dt, and the right hand side also can be obtained delta q on delta t delta t. The heat transfer rate q dot, and for the work we have the work rate, the power, the heat transfer rate. Q dot minus W dot. Therefore, the rate equation form of the first law obtained as this relation. We could also write as the first is E dE on dt Q dot minus W dot. The rate equation of the first law. The next section is about conservation of mass.